in this problem, we will prove that for every real number x, sine squared x plus cosine squared x is equal to 1. The first thing we will do is we will call our function f of x sine squared x plus cosine squared x. And now this function is defined on R and also differentiable on R, because we know that sine of x and cosine of x are differentiable, and the square of a differentiable function is also differentiable. Let's now calculate its derivative. So f prime of x is equal to sine squared x plus cosine squared x prime. And we also know that f squared prime is equal to 2f prime. So here it's equal to sine squared x prime plus cosine squared x prime. Now we will use our equality. It's equal to 2 sine x prime plus 2 cosine x prime. And we also know that sine x prime is equal to cosine x, and cosine x prime is equal to minus sine x. Now we replace here, we have it's equal to 2 sine x times cosine x plus 2 cosine x, and cosine prime is minus sine x. And I will continue here. It's equal to here 2 sine x cosine x, and here minus 2 cosine x sine x. 2 cosine x sine x, or sine x or cosine x is the same. Sine x cosine x. And here, since the same number here minus, this difference is equal to 0. Now we have proven that the derivative of our function is just equal to 0. What does it mean? That means that our function f is a constant. So f of x, which is sine squared x plus cosine squared x, is a constant. So let's evaluate it in, for example, in 0. Since it's a constant, f of x will be just equal to f of 0, which is, of course, sine squared of 0 plus cosine squared of 0. And sine of 0 is just 0, so it's 0 squared plus cosine of 0 is 1 squared. And of course, this number is equal to 1. And now we have proven that for every real number, f of x is just equal to 1. And that means, of course, that for every real number, since f of x is sine squared of x plus cosine squared of x, that means that for every real number, sine squared of x plus cosine squared of x is equal to 1. And this concludes our problem.